Hello. So today we are going to master control charts, a key tool for process excellence. Now, first of all, we need to know what is a control chart. A control chart is a statistical process control tool. It is used to monitor, control, and improve process performance over the period of time by distinguishing between normal and special cause variations. So if there is no special cause of variation, then we can say that the process is in control. Walter Short started the concept of control chart. It is used to differentiate between common cause and special cause of variations. The four techniques used for process control plans are standardization, documentation, monitoring plan, and response plan. So it is used to monitor, control, and improve the process performance over the period of time. That is the basic fundamentals behind control chart. Hello, this is Surojit Banerjee. I welcome you all to our channel, The Lean Six Sigma World, your go-to place for mastering Lean Six Sigma tools and techniques. So today, we're diving deep into the concept of control chart. We will explain everything in details about control chart. And the most important thing that you should know is that how to interpret any control chart, how to understand that the process is out of control. That also we'll cover in this video. So now we are moving into that why to use control chart. Basically, in order to sustain the improvement activities, we need control chart. It helps to detect the trends. It reduces the process variations. It improves quality. It helps to take the data-driven decision based on the actual data and not on assumptions. That's why control chart is widely used in various Lean Six Sigma projects. Now, we need to understand the types of control charts. What are the different types of control charts? Basically, there are two types of data: continuous data, or it is also called as variable data, and discrete data, or it is also called as attribute data. Now, for continuous data, we use X bar R chart, X bar S chart, and IMR chart. X bar R chart when my sample size is less than 8. X bar S chart when the sample size is greater than 8. And for attribute data or for discrete data, there are two things happen. One is defectives component and one is defects. Now for defectives, we use P chart and NP chart. P chart is for different sample size, NP chart is for same sample size. And defects, we use U chart and C chart. U chart is for different sample size and C chart is for same sample size. So these are all the different types of control charts that are basically widely used in any Lean Six Sigma projects. Now I am moving into uh, the key elements of a control chart. A control chart will have its center line. It is called the average. It will have its upper control limit UCL. It will have its lower control limit LCL and the data points, which basically shows the variations over time. Now the customer gives us the USL, upper specification limit, and LSL, lower specification limit. Now our process will be able to meet the requirements of the customer if my UCL and LCL is basically less or smaller than the USL and LSL. Then only the process will be able to meet the requirements of the customer. That's why all these key elements are very important to understand in terms of the meeting the requirements of the customers. Now I am moving into common causes versus special causes. Now any stable process, if there is some normal variations in the data points, we can say it is a common cause. But if there is some unexpected variations in the data points, then it is basically comes under special causes and it need attention, special attention. It need investigations. You need to do the brainstorming to find out what are the things that are happening, so that you can you can sustain the improvement activities and necessary actions to be taken accordingly. Now I am moving into the rules to detect the out of control conditions. So I am going to explain here 7 different points which are important to understand to know whether the process is in control or not. So a process is said to be out of control if one or more data points fall outside the control limits. 7 consecutive data points are increasing or decreasing in nature. 8 consecutive data points are on the same side of the average. 14 consecutive data points are alternatingly up and down. 2 data points out of 3 consecutive data points are on the same side of the average in the upward direction. 4 data points out of 5 consecutive data points are on the same side of the average in the downward direction. 15 consecutive data points are above or below the average. So these are the techniques, these are the rules by which you can understand whether your process is out of control or not. Now, key takeaways and action steps. Basically, control chart is used to maintain the it is used to maintain the process stability. Regularly analyze the trends. You need to regularly analyze the trends to prevent the defects. You need to act immediately whenever there is some special cause of variations in the process if you find, and keep improving the processes for sustain the quality to meet the requirements of the customers. You need to act promptly. So if you found this video helpful, make sure to like the video, subscribe to our channel, and turn on notifications for more insightful content. And share your thoughts in the comments below about the control charts, what you have learned today, or whether you have used control chart in your area of work or not, or whether you are planning to implement control chart in your area of work or not. Share that experience in the comments below. We'll be very happy and obliged to see that. And you can join our exclusive WhatsApp community to get free updates on Lean Sigma tools and techniques. You'll get all the updates and all the documents related to Lean Sigma tools and techniques for free. So stay tuned because we have more exciting Lean Sigma insights coming your way. Thanks for your valuable time. And thank you from the bottom of my heart for being part of this journey with the Lean Sigma world. Thank you. Thank you so much.